Okay guys, now we're going to talk about this graph. Y equals 1 over x plus 3. What's our parent function? For this, our parent function is y equals 1 over x. You guys should all know that by now, that's our parent function. And what's our parent function look like? Well, we know that we have a point right here, and we know that our asymptotes are approaching the axes. So there's an asymptote going like this, approaching the y-axis and the x-axis, and same down here. This is our parent function, okay? So we need to transform the parent function. We have y equals 1 over x plus 3. What is our transformations here? Well, do I have any horizontal transformation? Remember, the bottom part, what's attached to the x, tells me about my horizontal transformation. And it looks like I have none, because x is the same thing as x plus 0, or x minus 0. So I'm moving to the left or right 0 units, so I'm not moving to the left or right at all. Okay? For my vertical transformation, I'm going up 3. Okay? So my transformation would be up 3. So that is exactly what I'm going to do. But I want to first graph my asymptotes, because that is the most important thing for me here. Now, do I have a vertical asymptote? Well, how do we find out what our vertical asymptote is? If you remember, that's great, because it's really important. You set the bottom equal to 0, so x equals 0 is our vertical asymptote. And that is right here on the y-axis, x equals 0. If you're confused, know it's a vertical asymptote, so it's stretching up and down. What about my horizontal asymptote? This piece right here tells me my horizontal asymptote, and it's going to be at y equals 3. That will be my horizontal asymptote. Okay? Now I'm just going to go ahead and I'm going to draw my parent function, or not my parent function, I'm going to draw my new function. So it's going to be just shifted up 3. So that's my little center. But I'm going to draw one diagonally up 1 unit and diagonally down 1 unit and hug the asymptotes. See how the vertical asymptote is the same for our parent function and new function? Our new function, which is in green? Because we had no shift. We had no right or left shift. So that kept our vertical asymptote the same. Now let's talk about the domain. Well, if you're walking along the x-axis, okay, if I'm walking along the x-axis, I see my graph to the right, or sorry, to the left. Up until I get to this point, then I'll never touch the graph right here. But then when I move past that point, I keep seeing it, okay? Keep seeing it. So, I'm just going to undo that because it's making a lot of mess on the graph. So my domain is negative infinity up to my asymptote, which is 0, union with 0 to infinity, 0 to infinity, or x not equal to 0. What about my range? My range is, I'm moving up my y-axis. Do I see it to my left or my right? And where do I not? Well, I see it everywhere until I hit right here. I don't see it to my right, and I can't ever touch it to my left, because that's at the asymptote. So my range is from negative infinity all the way up to that asymptote, which is 3, in union with 3 to infinity, or y not equal to 3, because when we talk about range, we're talking about y. What other things might they ask you? Your interval of increase or decrease. Well, look at our green guy. Is our green guy ever increasing? No, it looks like it's always decreasing. Even when I start from here, it's decreasing again. So I have no interval of decrease. But my interval of increase, since an interval, we're talking about the x-axis, our interval of increase is the same as our domain. And I don't know why the 0 is gone from there, but it should be x not equal to 0 in the domain right there. So our interval of increase, since the function is always increasing, would then be the same as our domain right here. Okay. Now let's talk about the end behavior. Okay, what is happening as x approaches infinity this way? Where's y going? As x approaches infinity, f of x is going where? Talk about y. Y cannot go past this asymptote value right there. Y cannot go past this line, okay? And that line is at 3. So f of x approaches 3. Now what about when x approaches negative infinity? Where's y going? Again, y, as x approaches negative infinity, y, or f of x, approaches 3 again. Because it can't go past there. Okay? Now that we found all that stuff out, let's figure out what the y-intercept is. How do we find out what the y-intercept is to a graph like this? So let's see. Y is 1 over x plus 3. Let's just write it down here. I want my y-intercept, so I have y equals 1 over x plus 3. Remember, y is the same thing as f of x, okay? So if I want my y-intercept, what am I setting equal to 0? I'm setting x equal to 0. And let's see what happens when we set x equal to 0. We have y equals 1 over 0 plus 3. This is a problem. Can I ever have 1 over 0? And the answer is no. Now let's see. Let's go back here. Do we ever intercept the y-axis? Does it make sense on our graph? Look at the green graph. Do we ever intercept the y-axis? No, because I have an asymptote at the y-axis, so I can never even touch it anyway. So I have no y-intercept. No y-intercept. All right, that's it.